And welcome everybody to the Smash News Network, least busted name in news. I'm your host Dan, aka Smash-O-Mash, and we've got some major anomalies in the ionosphere, a huge reduction in cosmic ray flux, and more. First thing we're going to look at is the total electron content forecast. The electrons in between your GPS satellite and your handset can cause huge GPS errors. They typically occur around the equator at noon. Let's see the most recent. Again, we have huge anomalies in the ionosphere that we will get to here momentarily, as well as a cosmic ray update. But there are the most likely spots for GPS errors, and we do see a little bit of chaos here. So we see low levels of electron flux, but we see chaotic Van Allen belts. It's all associated with changes to the magnetic field and so on, folks. Electrons respond pretty quickly. Remember, they're only about 1/1800th the mass of a proton. No charging hazards at the moment. That's a good thing, as they can charge up the external and internal portions of satellites. Here's the one-year chart. We're at very low levels here of electron flux. No real surprise there, having just come out of a rather significant 15-hour geomagnetic storm. So there is the electron flux over the past 3 days, as measured by the GOES 16 and 17. There's the forecast model. That's by NOAA. Green boxes are the forecast, yellow diamonds are the observation. And next we're going to show the ionosphere, which again has some significant anomalies, especially in the southern hemisphere. The F-flare is what we're looking at. It's located at about 300 kilometers of altitude. So here's the F-flare and vibrational frequency. There's a lot of vibrating going on above your head. Again, we've got huge low-frequency anomalies in the southern hemisphere, and if you can't see them from the ionogram view, don't worry. We show the anomalygram as well. So let's bring that up next. Here's the anomalygram showing anomaly in megahertz from the 30-day median. You see all those red areas there around southern South America, the South Atlantic Ocean, South Pacific, South Indian Ocean, the Southern Ocean, and Antarctica. Remember, folks, March is the second most geomagnetically affected month, second only to September. So we can expect to see this for the next coming couple of weeks. What are you doing with your final week of winter? Or if you're in the southern hemisphere, your final week of summer? Here's the latest image. There's the ionogram from 11:30 Universal Time. There's the anomalygram from 11:30 Universal Time. And once again, low-frequency anomalies happening here around the Southern Ocean. Next, we're going to do a cosmic ray update. And if you see this massive dip in cosmic ray flux, that's the geomagnetic storm. That's the solar plasma, the coronal mass ejection arriving, greatly reducing the amount of cosmic ray flux here at planet Earth. A prime example of the way the physics works, perhaps. So that's Apatity. Down here is Barentsburg, and you're going to see a similar signal there at Barentsburg. A huge dip in cosmic ray flux as a result of the coronal mass ejection strike. Next we'll go farther south to Athens, Greece. There you can see a similar signal there at Athens, a major reduction in cosmic rays. That's a neutron monitor. And here is the Mexico City Cosmic Ray Observatory. Similar signal there. An indication that the data is legit. Remember, folks, 2 data points does not make a trend, but 3 does indeed make a pattern. Next we'll go a little farther north, back to Oulu, Finland. Huge dip showing up there at Oulu. And let's take a look at DOMB and DOMC Antarctica. There's DOMB, a similar graph there. And there's DOMC, a similar graph there. Corroborating the data makes it look legit, certainly. Next we're going to show the ground-based solar observatory at Cerro Tololo. And before we do that, let me check the life of the stream here. Everything looks A-OK. This video was originally streamed live to Twitch, by the way, at twitch.tv/Smash-O-Mash. Perhaps install the mobile app, as it will actually notify you when we go live. It's just a great live streaming platform, so we use it on the regs. So here's what's going on at Cerro Tololo, the ground-based solar observatory, part of the National Sunspot Observatory. Some current imagery there. Let's move on to the latest intensitygram and latest magnetogram. Not a lot of major changes happening here. Sunspot 2960 looks like it's become an alpha class sunspot. This sunspot back here is, I think it's still beta class, but it's very tiny. There may be some active regions rising here. We'll cover that in a later video. 2965 is still quite capable of producing additional flares. It just produced an M-class flare. Here are the fields. It is a beta gamma class sunspot. Anyway, here's your rock back and forth. Also, thanks to the Smash Team. Consider becoming a member of the Smash Team at smashaMash.com/SmashTeam. If you prefer to see these videos continue to exist, remain publicly visible, and free for all to view, smashaMash.com/SmashTeam. Links below the video in the description, as well as on our homepage at smashaMash.com. Here's the GOES 16 SUVI wide field of view in ionized helium, 304 angstroms. We've actually captured the M-class flare there. You can see that M-class flare happening right there from sunspot 2965. Still the most likely place to produce additional large flares. And we'll just give you a little idea here of how to browse data. So if you head to the SDO The Sun Now page, you click AIA HMI Browse Data, put in the dates you want. These are the days we want. We're going to bring up the colorized magnetogram and 171 angstroms view. Spectacular imagery there from the SDO from yesterday and today. And that's where we'll have to end our bonus feature segment. Thanks for tuning in, folks. Don't forget to press like, subscribe, share, tell your friends and foes about us. We're not sure the algorithms are doing so. And may that solar wind be at your back.